Okay, so for this question, they ask you to find the value of the line integral, and if f is conservative, then the integration may be easier if you use the alternative path. So I'm gonna test to see if f is conservative. So f xy is y e xy and x e xy j. So I'm gonna name this m. I'm gonna name this n. So partial of m respect to x is the same thing as partial of n respect to y. So, oh, it's the opposite, I'm sorry. Okay, it's the opposite. All right, so if this true, then your f is conservative. Okay, so now I'm gonna take partial of m respect to y. Partial of m respect to y. Okay, so respect to y will be e to the xy plus see here xy e to the xy. Now partial of n respect to x be e to the xy plus xy e to the xy. Since they are exact, they are equal to each other, and your f is conservative. So now now your f is conservative. You can apply the theorem, the fundamental theorem of line integrals. So I'm gonna find the initial point and the terminal point by plugging in 0 into the equation and 7 into the equation to find the initial and terminal points. So for the initial point, if I plug in 0, I would get 0 minus be 7, and terminal point is 7 0. Alright, so now I'm gonna find the potential function. So you're gonna take the partial integral of f respect to x and then y respectively. So you have y e to the xy, x e to the xy. Now you're gonna, this is your f, this is the given function from the beginning. I'm gonna take the integral respect to x right here and then respect to y right here. So if I take the integral respect to x here, I treat y as the constant. So I have y over y e to the xy, and then you have x over x e to the xy. So this cancels, you get e to the xy, and this is your potential function. After you get the potential function, you can apply the fundamental theorem of line integral. So we're going to name this y fxy fxy. So now f 0 7 minus f 7 0. So I'm going to plug in 0 for every x, 7 for every y, and oops, I messed it up. Supposed to be terminal minus initial, so it will be 7 0 minus 0 7. Alright, so 7 for every x, 0 for every y here for the terminal points, and then 0 for every x, 7 for every y for the initial points. So 7 for every x, 0. So you have 1 minus 1, because you have 0 for the exponential. e to the x e to the 0, you get 1, so 1 minus 1 is 0. So your A answer will be 0. So this is your A. And then let's do B. B states that the closed path consisting of the line segment from 0, 7 to 0, 0, from 0, 0 to 0, 7, and from 7 to 7, 0 to 0, 7. So as you can see, they are symmetry. Like our A questions right here, where we have initial and terminal points are flipped from each other. But we're gonna find this by separating each part into C1, C2, and C3. So for C1, you will have F 0, 0 minus F 0, 7, which gives you 1 minus 1 equals 0. Okay, and then C2 will be F 7, 0 minus F 0, 0. 1 minus 1 equals 0. All the ones I'm plugging in these values into the potential function right here to get the C1, C2, and C3 right here. So F 0, 7 minus F 7, 0. So 1 minus 1 equals 0. So C equals C1 plus C2 plus C3, where C1 is 0 plus 0 plus 0. So your answer for B will be 0 also. What I did here for C3, C2, and C1, I took the terminal points, I plug it into the potential function minus the initial point into the potential function. So that's it.